kind of a quick heads up on JourneyTEAM, but I think we've got a lot of customers on, right, who know who we are already, and so appreciate you being here. But we also have quite a few folks who don't know who we are, and maybe this is the first time getting to know JourneyTEAM. So just really quick snapshot of us: 130 consultants, but 160 total employees here at JourneyTEAM. We're currently working with about 350 active customers at any given time. We've been doing this for, almost 30 years. We take a lot of pride in our referenceable customers. About 90% of the clients that we work with us come back for more and keep working with us. So we're really proud of that, and something to kind of hang our hats on. We do, one thing that's important to us is some of the success we've had in the past. If you were to come in the office, you would see some of these awards, but since you're not here, we'll just kind of highlight them here. We've been Partner of the Year many years with Microsoft, and take a lot of pride in that. So I will skip past the majority of these, but more or less just want you to know a little bit of who we are. I think this is probably the more important thing to talk about. We are talking about data warehouse today, which is super important. And as we look at forecasts and things going on in the world today, this is a massive need for a lot of organizations, and we know that. I do like to point out that this is not all we do, right? So we do a lot of data warehouse work. However, once we've collected all that data, we do a lot of work on the Power BI side and presenting that data. We do a lot of work on really anything from a Microsoft standpoint. We are a full service Microsoft partner, whether you need a new ERP solution. And that's whether you're a smaller organization all the way up to the enterprise. We have needs to address those. CRM, field service, all kinds of different automations on the customer service side. And then on the cloud space, so anything Microsoft 365, we do migrations from G Suite to Microsoft 365. We do all kinds of different security and fun things there. And then a lot of intranets, SharePoint work, and data and BI. So probably the most important thing as well is the change management and adoption. All these things really fancy and cool, but unless you get your employees to actually use them and adopt them, then they somewhat fall flat. So we spend a lot of time on that as well. That's a little bit about us. I'm going to turn the time over to Jason. Jason's one of my favorite people here at JourneyTEAM, and I think you guys are all in for a treat. One other just quick reminder as we get going, again, chat feature with any questions, please use it. I am going to post a survey. We'd like you all to fill that out, and there's a $50 gift card for kind of a winner. We'll do a drawing at the end of that for all those who filled out the survey for this session. So with that, Jason,
Yeah,
you're up.
sounds good. Thanks a lot, Landon, and thanks to JourneyTEAM for giving us this opportunity to talk about modern data warehousing. Just happy to be here and share this time. I plan on probably ending within 45 or 50 minutes, so there will be time at the end to bounce questions back and forth. So happy to open it up to any questions at the end. A little bit about my background. I've got almost 25 years experience in information technology, and about 22 of those years has been directly associated with Microsoft data technologies. I kind of started out my tech career getting the certifications back when certifications were just worth their weight in gold, more so than today. Started out with the Microsoft Certified Systems Engineer, and then I moved quickly into getting the Microsoft Certified Database Administrator certification. And then more recently, some Azure certifications, Azure Fundamentals, and Azure Data Engineering. Have a lot of a variety of industry experience working with for a lot of different companies. And then especially now, my time spending as a data engineering manager here at JourneyTEAM, have a great opportunity to work in a lot of different industries. So happy to be working for JourneyTEAM as a Microsoft Gold partner. Okay, so first item of business is a little bit of a pop quiz. We've heard this word pronounced in many different ways. And if you can read lips and look at Satya's lips, you might be able to discern how to pronounce that cloud platform. So start out with this little video to answer that important question.
If you visit Microsoft's EBC and ask an employee how to pronounce the name of their cloud product, They will tell you that everyone says it like their CEO does, which rhymes with the word
pressure, 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 pressure.
This fundamental fact that Azure, we have Azure, the Azure Digital Twin Service. This very rich cloud infrastructure in Azure. That's what we are building with Azure. Azure.
And Microsoft Azure as its cloud platform.
On platform Azure.
Azure VPN Gateway.
Microsoft Azure.
Azure.
All right. Now that we've got that cleared up, we all have received our money's worth, right? As we know how to pronounce that word. Talk about Microsoft Azure data technologies today. It's pronounced a lot of different ways, and when you're in different countries, it's pronounced a little bit differently, but thought that would be a fun way to clear that up right off the bat. So I'll be saying Azure. So hopefully I get a pass on that for today. So hello, I am Jason. I am a data nerd, and I've tried to talk my kids into thinking that was cool. I'm having a hard time convincing them, though. When they've had school assignments to come and shadow someone in their career and during their day job, I've quickly volunteered to say, hey, I've got an awesome, exciting job as a data engineer. Why don't you come and shadow me? And so I even said, I'll buy you lunch. You get free lunch. You can shadow me and just see magic happen. And so the result of that is like, well, they get bored. They come and sit by me and it's boring, Dad. That's what you do. Data engineering, that's data nerds, it's just boring stuff. So I'm failing at converting them into considering IT as a career, but I'll keep trying.
It is true. I met Jason's son one time, and he did say his dad was a data nerd. So validated. It's accurate.
Thanks. Right on. All right. The jargon jungle. So today we're going to throw out and consider and analyze a few of the current catchphrases and taglines and some of its jargon. So this is a Dilbert. Do we have any actionable analytics from our big data in the cloud? So there's two jargon words. Yes, the data shows that my productivity plunges whenever you learn new jargon. Maybe in-memory computing will accelerate your applications. So just pointing out that sometimes jargon is just that, jargon. And so this Dilbert is about 10 years old, back in the day when big data was the big craze, right? Every company knew that they had to get into big data, and there would be big benefits from embracing big data and investing big money into big hardware to facilitate the big data, to pump the big data in, right? We don't hear as much about big data now. All data is important, small, medium, large, big. What was big 10 years ago might be small or medium-sized data set now. The other catchphrase there, though, cloud, we need to embrace the cloud. We need to get on the cloud. 10 years ago, there was a much slower adoption at that point in time. Me as a data engineer, I was sitting thinking, cloud, how would you get all of this, terabytes of data up into the cloud? I mean, how would that work? All of our ETL tools, the extract, transform, and load tools are on-prem, and we have our servers and our data center, and the applications are on premises as well. So it was a little bit slower adoption 10 years ago, but it's increasing, and the benefit of leveraging cloud is definitely here today. So the point being is some jargon is just jargon. Some jargon may be beneficial for us to consider and embrace and implement. Okay. So the goals for today, the outcome that I'd like to drive towards is just consider the idea of modern data warehousing. What is it? What makes it up? What are some things in the past that provide still some useful foundational layers, like concepts like data warehousing, some of the newer concepts like data lake and even data lake houses, how we can consider these design patterns in helping us implement data warehousing solutions within the organizations that we work in. I'll also talk about 5 steps in modern data warehousing, and then how each one of those steps align with a Microsoft Azure platform or service. But at the end of the day, we're all wanting to know how we can gather business requirements and provide actionable insights off of gathering that data and loading it to be able to provide an opportunity to make better business decisions. So that's the end goal. Okay, so first, I grew up in the 80s when things were totally radical. I had some Converse All-Star high top shoes. I also had some Vans. I also tried a mullet, not quite as awesome as that mullet. I remember me and my friends would save up our quarters and then, use some of those quarters to hit the gas station on the way back when gas was like $1.20 a gallon, to go to these arcades. And then there was the invention of nickel arcades, where you could play 5 games with that 1 quarter. The arcade games were a little bit older, but for a nickel, you could play awesome, totally radical games like Pac-Man and Space Invaders. Also in the 80s, we had boom boxes and ghetto blasters. I had a ghetto blaster, but maybe not as cool as that guy's ghetto blaster. And my mullet was definitely not as rockin' as that dude's. So the 1980s, just to make a comparison. So in the 1980s, we had Vans shoes, Converse shoes, and mullets. Well, the modern equivalent would be Vans, Converse, and mullets. We're seeing all of those things today. So some things stay the same. In the 80s, we had boom boxes, and the modern equivalent would be our phones. We don't need a boom box. We can listen to music on our phones. Arcade games. The modern equivalent would then again be our phones. Our phones can store, have access to hundreds of games if we want. So phones, LOL. So that's a modern invention, and I just learned that the plural of LOL is LOLs. So some things get better, like boomboxes and arcades, evolve into phones. And then some things are invented, like LOL and LOLs, and then the equivalent in the 80s would be just sitting in a room together with a person and laughing in person. So some things stay the same, some things get better, some things are newly invented. So how do we compare that with data warehousing? Well, in the 80s, to design and build out a data warehouse, it meant big iron, which meant big bucks. So big iron in the context of ordering all these servers from a provider that shipped those servers. It took maybe a few weeks or a few months for those to arrive. We'd go into the data center and unpack all these boxes and then plug all these servers together and put them in racks on the data centers. We'd also have loads and loads of hard drives that we need to plug in. We need to configure that hard drive array to be able to have storage. So a lot of time and a lot of money to build out these systems. So the modern equivalent is just to leverage cloud. If we need to spin up a resource in the cloud, it's a matter of opening a browser and clicking on what you need and having it be immediately available. In the 80s, what that big iron meant was large capital expenditures, millions of dollars to bring these servers into a data center to build this out. And then come to find out 2 to 3 years later, it would be antiquated, out of date. So you'd need to order another set of hardware to upgrade what you have to continue scaling up. The modern equivalent is, again, leveraging cloud, going more from a CapEx, capital expenditures, to an OpEx, the monthly cloud subscription cost, where you only are charged for what you use, as opposed to in the 80s, if you build out $1 million system and only use a fraction of that to begin with, you're not realizing that investment. In the 80s, data warehouse systems were complex, slower to deliver, and then the modern equivalent is oftentimes less complex with quicker returns. In the 80s, the systems were monolithic, in that it was built, all of the parts of the solution was built within a box, so it was very difficult to take one piece out and enhance that and run it through tests without affecting other pieces of the solution. The modern equivalent is a modular build where we're able to segment and separate different pieces of the solution to bring it outside and enhance, test, and validate. The solutions in the 80s had more rigidity, and then the modern equivalent, more pliability and agile. In the 80s, if we think of the analytics solutions, we think of these preset reports, maybe a daily, monthly, quarterly reports, and then the modern equivalent is more self-serve analytics. In the 80s, no AI or ML, and then the modern equivalent would be integrated AI and ML. So a few definitions, just to provide some foundational ideas. Data warehouses are central repositories of integrated data from one or more disparate sources, and they store current and historical data in one single place that is used to create analytical reports for workers throughout the enterprise. So the modern data warehouse is very similar with a few differences, and I've highlighted those. So the idea of modern data warehousing, it can scale up or scale out very easily. The modern solutions have dashboards and advanced analytics. So a little bit similar, but with additional functionality and scalability. One defining element that the modern data warehouse still has that's beneficial is this idea of a dimensional model, where you model out and define what your business process is, and you create measures around the business process. So for this example, it would be customer sales, and then unit sold, and then dollars cost. And this can be categorized as it's related to all of these dimensions. So when we think of modern data warehouse, sometimes we think of doing away with what was in use in the 80s. But as we've established, some things in the 80s are still useful and still a thing today. And that one of those things is the dimensional model. If we didn't have a model somewhere in our solution, we wouldn't be able to answer questions like how many units were sold from promotion A for a customer demographic by time. We can answer that because we've built out this dimensional model with the corresponding relationships. Okay, so let's draw some comparisons. Data warehouse versus modern data warehouse. Data warehouse ingests data from multiple sources, usually structured or relational. Well, the modern equivalent are those things plus being able to ingest semi-structured or unstructured. Data warehouse, usually based on that dimensional model that I just had up, which is a Kimball dimensional model, a star schema. Modern data warehouse also has support for big data and integrates ideas like data lake, which we'll talk about in a few minutes. Data warehouse traditionally are batch loaded, so large amounts of data coming in and loading the data warehouse at the same time. And then modern data warehouse also offers streaming and near real-time feeds. Data warehouse, the model must be built before the business can gain insights. So a little bit of rigidity there, where the modern data warehouse also provides, when we think about the idea of a data lake, quickly moving data from source into the solution, and then providing immediate opportunities to look at the data and do discovery. Data warehouse is often built on an enterprise relational database engine like Oracle or SQL Server or DB2. Modern data warehousing also has relational databases available, but also gets into data lake technologies like Azure Data Lake Storage. Data warehouses, to improve performance or to accommodate additional load, you're typically looking at scaling up. So the example that I gave earlier is, well, you need to sink more money to buy more hardware to bring it in to be able to scale up more. Modern data warehousing is easily scale out. Data warehouse is usually on-prem or cloud, and then modern data warehouse is cloud only, so where you have that capability to easily and quickly scale out. Another improvement in modern data warehousing is in regards to how you get the data into the solution. Previously, the common design pattern was extract, transform, load, where data would be extracted, transformed within an ETL tool, and then finally loaded. So you would just have one copy of the data that's been loaded. The new paradigm is ELT as opposed to ETL, where you extract, load the data, just get the data from point A to point B in a raw, untransformed state. And then once it's loaded, then you iterate through your transformations to provide that benefit of a faster load time initially, and then modularize the transformations. What this also does is it provides you with lineage. If you're looking at something in this transform layer and you're wondering where it came from, you could go back into where it was loaded in this data lake concept to be able to provide that lineage. It also provides an area to make discoveries sooner. Is it right when the data is loaded? You can provide that opportunity for data analysts or data scientists to immediately gain some insights. Okay, so to wrap things up on a modern data warehouse, this is kind of a real busy slide, and so sometimes it is as easy as pressing the easy button. The idea of going out to the portal on Azure to spin up whichever resources you need out of this diagram. For example, you may only need 2 or 3 of these resources. And in that case, it is like pressing the easy button to go out to the portal on Azure to get you up and running. This, on the surface, may look confusing or complex, and it could be, but the point is I believe the best approach to take is not necessarily to be constrained by a preset pattern and throwing all the requirements through that pattern and process, but to gather the requirements first and discover which platforms and services you need to develop the solution. So, okay, so what is a data lake? So a data lake is a centralized repository, and we've talked about this, that just gets data from point A to point B in the original form. So in a raw state that's not transformed and made available for analysts and to do discovery. So a few data lake use cases. Back in the big data days, there were 5 V's. V is in Victor, 5 V's, and I can only remember 3. And I don't really like the other 2, so here are the most important V's as far as I'm concerned, and it applies to data lake use cases. So when should we use a data lake? Well, when we have high velocity. And the example here is an international manufacturing business that has multiple manufacturing sites throughout the world, and the tools within the manufacturing line produce millions of outputs, IoT, high velocity per second. And so that's an example of high volume, high velocity to pump and stream directly into a data lake without being encumbered by any transformations. The next V is volume. So very, very large volumes of data. You can think of social media feeds, Twitter, Facebook, just very, very high amount of volume. The idea there is just to pump it in data lake that's very performant and scalable on loading data. The other V is variety. That encompasses a variety of formats like XML, JSON, CSVs, relational, any kind of variety can be pumped directly into the data lake. These examples over here, I think that these use cases could be applicable to data lake, but I also think they're applicable to connecting to a dimensional model as well. And so that's why I kind of put the question mark that yes, this could be a use case, but a dimensional model could also be very applicable as well. Okay, so data lake versus data warehouse. Data lake can accommodate structured, semi-structured, and unstructured. Data warehouse is typically in that dimensional model or relational database structured. Data lake, both formats, data warehouse, relational. Data lake is schema on read, and so as data is being pumped into the data lake, and then you want to read it, then you've got to overlay and define a schema to be able to read these many, many files. Data warehouse, the schema is defined as the data is written, so when you want to read it, that schema is already defined. Data lake, the data going in is raw and unfiltered, and then data warehouse, it's processed, vetted, it's underwent some transformations and some modeling. Data lake, big data, IoT that we pointed out earlier, as well as social media and streaming. Data warehouse is more so applicable for application business, transactional, and batch reporting. Data lake is easy to scale out, as we pointed out, at low cost. And then I'm making the argument that the modern data warehouse is also easy to scale out at a low cost. Data lake, I believe, has the same use cases between data warehouses, is that idea of they can connect to either schema on read data lake or schema on write a data warehouse. Data lake provides opportunities for machine learning, predictive analytics, and real-time analytics. Data warehouse also has the capability for like the idea of core reporting, BI, and analytics connecting into that dimensional model. Okay, so warning alert, some jargon is coming ahead. So data science and AI, very, very hot, awesome. We all want it. We all need it. We all love it. But sometimes we forget about data quality. So that's why I'm a few slides earlier, I said, well, data scientists not only love to connect to data lakes, but the thing about data lakes is it's dirty, it's raw, it contains null values, as this cartoon is pointing out. So sometimes to improve the quality, data scientists can connect to a nice data warehouse dimensional model to avoid any gotchas there. Okay, so here's another jargon word coming, and I've been resistant to this idea of data lakehouse. Like, what is a data lakehouse? Is this just kind of another jargon term that is going to be a fad or a dying breed. But the more I've built out solutions leveraging Microsoft Azure data technologies, the more I recognize and realize that the Lakehouse is emerging of the benefits of both data lake and data warehouse. So what is a data lakehouse? So data lakehouse is an open standards-based storage solution that is multifaceted in nature. It can address the needs of data scientists and engineers who conduct deep data analysis and processing, as well as the needs of traditional data warehouse professionals who curate and publish data for business intelligence and reporting purposes. So that's the beauty of a data lakehouse, is if you need more of a heavy load with high performance and easy scale out, you'll want to have a data lake component to the solution. But if you also have a requirement to clean that data, undergo some transformations, and to get that modeled out into a nice star schema for an analytics tool like Power BI to connect to, well, then you would have both. You would have a data lake and a data warehouse components, and that by design is referred to as a data lake house. So comparing data lake versus data lake house, they're very similar. So in structure, can accommodate both types of data formats. One difference that Data Lakehouse provides is schema on write. So again, bringing in that data warehouse component where you can have that capability. It's more of a design pattern. There's also a concept of Delta format files that provides incremental loading based on deltas that have been predefined, but that's also an open source design pattern. Data Lake accommodates all the different types of data. Data Lakehouse, same thing, but then again, it pulls in the traditional data warehouse capability to accommodate. Data Lake is easy to scale at low cost, and I would argue that the modern data warehouse paradigm provides that same capability. And then data scientists like the idea of a data lake, I think mainly because they can get their hands on the data at the earliest point possible, as opposed to waiting for the transformations and the modeling to occur, which takes time. Machine learning and predictive analytics can be realized through both solutions, but again, Data Lakehouse brings in those traditional benefits of data warehouse, core reporting, and BI. So if we look at some architectural slides to compare the differences and the idea of bringing in data warehouse patterns and practices and benefits, as well as data lake into this data lake house. And this is a slide published by Microsoft. I'm not sure why they leave out some of the data lake components. Like here, the paradigm is data lake is able to accommodate many different types of data formats, relational, blob, image, video, files, API, whatever you can think of accommodates that. You've got this function here, ETL, which in a modern paradigm, it should be ELT. So you load first, extract, load, and then transform and model into this data warehouse area. So I think that these benefits can be pulled over into this data lakehouse area as well. Okay, so this is a pretty cool video that the CEO of Microsoft gave 4 or 5 months ago that provides kind of a vision and a roadmap indicating that analytics should no longer be considered a separate, isolated solution. So let's hear this from Satya.
And today, I'm very excited to announce the Microsoft Intelligent Data Platform. There is no better example of why this matters than e-commerce. Take, for example, a shopping website that needs to create personalized experiences, including product recommendations. Real-time personalization means the website needs to capture new interests from current sessions and instantly match historical data to online session data in real time and at limitless scale. It's absolutely mission critical during peak events like Cyber Monday. The site needs to connect and correlate customers with products, inventory, suppliers, logistics, and even social sentiment, all while respecting customer data privacy. They can build their application on Cosmos DB or SQL Hyperscale. With Synapse Link, all committed transactions across these databases are now available in real-time analytics in Synapse. With Azure ML, they can easily retrain models based on this real-time learning and close the loop by deploying those models back onto the application. And with Power BI, insights can be shared across the company. All of this can happen within just a few seconds. So the website can offer the right product to the right customer at the right time. And of course, your service has to ensure it's compliant with GDPR and other privacy regulations. And that's why we have deeply integrated all of our data services with Microsoft Purview, enforcing governance across all these data assets wherever they reside. This is about bringing together all of our data products into one architectural fabric so you as developers can shift your focus to your creativity, to what you can uniquely do instead of spending time integrating data services and governance.
So that's pretty cool stuff, and this is a slide that complements what Satya just went over. This idea of analytics not being an isolated platform or solution, it's merged together now with data governance. He mentioned Microsoft Purview, which has just been released within the past few months. Here at JourneyTEAM, we've got some POCs started on that and just doing some discovery and some builds on how that can complement to provide data lineage and data governance and just tie things together in a nice way. So it's pretty exciting ecosystem to be a part of and build solutions from. Here's another slide of, and now, so Satya is referring to this as the Microsoft Intelligent Data Platform. And if you look at the shape, it kind of looks like a house, right? It's got a roof up here and it's got rooms and a basement foundation. So the foundational layer is the data warehouse and data lake here, which provides the foundation for this idea of data lake house. So that's pretty cool to see that. The tool that they showed was Azure Synapse Studio, just all within one interface to pull in all of the different platforms and services and capabilities into that one tool. It's awesome stuff. Okay, so if we kind of map out this Microsoft Intelligent Data Platform, and then identify the modern data warehouse steps along the data pipeline process. So step one would be to ingest. If we're looking at the different types of source data available, that's step one, is to connect to that source, pull that data in, and then step two would be to store that in this data lake area. And a data lake can be either Azure Data Lake Storage, or it can be an Azure SQL database. So if you're pulling source data from a relational database, sometimes it's easiest just to pull that directly into relational database instead of to Azure Data Lake Storage, which is just kind of like a folder store with files and folders. So once the data is ingested and stored, then the next step in the modern data warehouse paradigm is to transform, to gather business rules and transformation logic which can be as simple as doing column renames to being more complex, like merging and joining and performing business logic and formulas within this transform step. The next step is to create that model. And the idea of, okay, if you have an analytics tool, it loves to connect to a predefined model with keys that provide relationships between facts and dimensions. And then the last step would be to visualize. So that's the modern data warehouse paradigm along the data pipeline. If we now take this and then align it with corresponding Microsoft platforms, tools, or processes, step one, that ingest step, would be to use an Azure data pipeline tool like Azure Synapse Studio or Azure Data Factory, which Satya had up on his slide presentation in the video. Step two, the place that we're able to store after we ingest is Azure Data Lake Storage here or Azure SQL Database. And this would be considered that data lake area of the data lake house. Step three, we'd also leverage to do our transformations. We'd leverage Synapse Studio or Azure Data Factory, as well as getting that all modeled out. We'd use the data pipeline tool to do that as well. And then step five is to visualize. We use Microsoft Power BI, which has been best in class, best of breed for years and years and years. So that's awesome to have Power BI be the capstone to this Microsoft ecosystem and solution. So if we look at what we have, let me go back one. So what we are providing at JourneyTEAM is we're providing building out this solution, all 5 steps, taking up to 2 data sources, either relational or CSV, and up to 15 entities, pulling them into this data lake area, undergoing transformations required, and building out a model, and then also building one Power BI report. We've kind of packaged this solution up, and we're calling it the Data Lakehouse Fast Track. If you have any questions on that, please reach out and let us know how we can help you. The parameters down here indicate that as part of this package solution, a JourneyTEAM data engineer would be available, a JourneyTEAM data architect, and a project manager to move the project forward. The timeframe target is 4 to 6 weeks to complete this. We just felt like that was a good timeframe to go after. The perception sometimes that businesses have is that a data warehouse is just too big, too expensive, it takes too long to build. But with the modern paradigm, leveraging Microsoft Azure cloud platforms and solutions and practices, we're able to show that we can build out the initial data lakehouse solution within 4 to 6 weeks. Up to 15 entities to go through the entire process end to end, and then which includes the transform logic, to any data type conversions and the surrogate keys required in the model here with any minimal calculated columns. And what we're doing as part of this Business Technology Summit is, I think we're doing, I can't remember, Landon, what we're offering, but the first however many people that respond to this get a 10% off of our listed product price. So Landon, maybe you can clarify that and talk about that, and then as well as address any questions.
Yeah, anyone who wants to take advantage of this offer in the next 2 weeks would be available to take advantage of that. So the way to go about that would be to reach out to, if you're a current customer, reach out to your current account manager or myself. If you're a new prospective, customer, then you're welcome to reach out to to me. So, yeah, if there's any questions, we've got a little bit of time left. We've actually got about 15 minutes. So if there's any questions, you want to try and stump Jason, then it sounds like a lot of fun. Let us know in the chat. Okay, we do have questions from Thomas Day. Do you see that?
Yeah, we've got one question here from Thomas Day. His question is, can you have a data lakehouse environment without using Synapse? And I think the question is yes, Thomas. The idea of a data lakehouse isn't tied to a Microsoft technology. It's an industry practice and design pattern. And so if you look at this, this design pattern here, you may have a use case where you have high volume, high velocity data that you just need to get pumping into a data lake. And so you may only need to use one portion of the solution. You may not have a need to, you know, create, you know, operational reports or create any analytics at that point in time. So you wouldn't need to create the dimensional model, which would indicate that you wouldn't need to model that out in a relational database like Microsoft Azure database. So I think it just depends on the use case, what the business requirements are, to be able to ascertain. A few previous slides ago is when I put up, you know, kind of the slide where Microsoft kind of shotguns out all of the different features in Azure. You may only need one or two or three of those services. So yeah, I think that's a good question. I think it's important for us to remember not to confine ourselves with one particular design practice or pattern. We need to gather what the business requirements are and then build a solution based on those requirements. So good question. Any other questions? So one from Joe Buckwalter. Would you still recommend the Microsoft stack if a majority of the source systems reside in AWS or on-prem? So that's a good question, Joe. I think if we look at this paradigm of building out, you know, a modern data warehouse or data lake house, if the source is in AWS, then we just treat that like a source. And what we would do is we'd pull that source data into the Microsoft ecosystem. We're a Microsoft consulting firm, so all of our solutions use and leverage the Microsoft stack. And then if your other part of the question is if the majority of the source system was on-prem, Azure provides some awesome functionality within Synapse Studio or Azure Data Factory. There's an integrated runtime that runs in cloud, but there's also a self-hosted integration runtime that you install on-prem that acts as a gateway to any of the data sources that you have on-prem. So they've provided a really compelling and easy story to be able to ingest both, you know, from another cloud data source like AWS or from any on-prem data sources. So hope that gave you some ideas there, Joe. Yeah, looks like there's one more question here.
Got more.
So from Jared Sorensen, for Transform, are you using Azure Databricks? Or what services are you using to do the transform? Okay, good question, Jared. So Databricks, the use case there is if you're pulling in a substantial amount of files, unstructured data into a data lake, then you'd look at using and leveraging Azure Databricks. So in this paradigm, the tool to do the transforms would be Synapse Studio or Data Factory. And from within those Azure data pipeline tools, you can pull in and create Databricks pools and clusters, and to be able to leverage that. So you can bring any, and I guess what the awesome thing about this current modern data warehousing paradigm from Microsoft is that they're embracing a lot of open source paradigms and um, just procedures and standards. So one is the Delta Lake paradigm and the data lake, and then the other is Databricks. So any knowledge or experience you have outside of the Microsoft ecosystem, like has in the past has been like Microsoft SQL Server, Microsoft SQL Server integration services, analysis services. Well, now the Microsoft ecosystem in the cloud is leveraging and embracing a lot of open source tools, technologies, and design patterns. So hope that answered your question.